So the last set of basic functions with level 6.5 are the tangent and cotangent functions. And I saved these to the end because tangent and cotangent involve sine and cosine, but their graphs look nothing alike. So we will get to something that looks like this with our last section with level 6.6, and we'll throw all of those together. Here's what I want us to think about just real quick. If you have your unit circle, that would be great to have out, because we're going to kind of walk through some of the properties of tangent so that we can look at the graph. First off, tangent is the y value over the x value. And what happens with tangent is at our normal, easy to look at angles, and if we go a second time around, this would be 3 pi over 2. Here, tangent would be 0 over 1. Or, sorry, this is 1 comma 0. So tangent at 0 is 0. Tangent at pi is 0. Tangent at 2 pi is 0. Tangent at 3 pi is 0. Tangent at 4 pi is 0. These all just would be 0 over a number, which is going to be 0. What happens, unfortunately, with tangent is when we are looking at pi over 2 and 3 pi over 2, we have 0 comma 1 or 0 comma negative 1. Well, tangent here would be 1 over 0, so it's undefined. Same thing at 3 pi over 2. It's undefined here. So every multiple of pi over 2, we get an undefined value. And more so, tangent only takes from 0 to pi to repeat. And these are a lot of things that go on when we're dealing with tangent. So I've listed out some of the properties here. The domain of tangent is the set of all real numbers except odd multiples of pi over 2. And that's because we get undefined. This is where we get vertical asymptotes. The range is a set of all real numbers. So unlike sine and cosine, that the largest values are 1 and negative 1, tangent can be often to positive or negative infinity. The tangent function is odd, which means, if you remember from level 2, it's symmetric about the origin. And the last bit, tangent is periodic with a period of pi. So unlike sine and cosine, it only takes halfway around to get one cycle of tangent. And this is the thing that throws most people off. We don't normally use, so our formula is 2 pi over b for sine and cosine. For tangent, our amplitude stays the same. Our period, though, is only pi over b, because it only takes pi revolutions to complete one tangent cycle. So hopefully this will clear up some things so that when we try graphing tangent, it makes a little more sense. So our amplitude normally is 1. Our period is pi. But we don't get nice start and finishes here. And I'm just going to graph this before I write out the start and finish. So normally we start at 0. The tangent of 0 is 0. Remember, tangent here would be 0 divided by 1. The tangent of pi over 2, if I go just this step, pi over 2, if we look here, is 1 over 0, which is undefined. So we get a vertical asymptote at pi over 2. If I go another half circle at pi, well, at pi, tangent is 0. If I go another half cycle, so this is pi, if I go another half cycle, I get 3 pi over 2, which again, tangent is undefined. So our starting spot at the origin, we don't get a full bracket. So if we went back another half step at negative pi over 2, we'd also be undefined. So the thing that throws most people off is that we say tangent, we graph from negative pi over 2 to pi over 2. But we're having vertical asymptotes every odd multiple of pi over 2. So we could easily say that this is one graph, or from here to here is one graph. And then what throws everyone off is the period is pi. So why don't we go from 0 to pi? Well, 0 to pi, 0 and pi, is not where we're undefined. What we're undefined at is the multiples of pi over 2. And this, from negative pi over 2 to pi over 2, is 1 pi. So the last little bit. If I cut halfway between here and here, say pi over 4 and negative pi over 4, on our unit circle, the tangent of pi over 4 is 1. And the tangent of negative pi over 4 is negative 1. And so tangent turns out to look just like this. Only it repeats itself. So then if we wanted to include more pieces, from pi over 2 to this would be 3 pi over 4, and this would be 5 pi over 4. We would get 1, and we would get negative 1. And this same cycle repeats itself over and over and over, every pi over 2. So tangent doesn't play nice with our nice start and end formula. So if we have our vertical asymptotes at every odd multiple of pi over 2, then we're going to start, and I like to just start negative pi over 2 and finish at pi over 2. And the distance from here to here gives us our period. Okay, this is why we save tangent for the end. Let's flip it over and try a couple more. All right, so looking at example 2, we're going to look at the amplitude, which is going to be 3. Next up, I'm going to write the formula for tangent's period, which is pi over b. So that's pi over 2. So our period is pi over 2 now, and we're stretched just a little bit. So we're going to finish is going to cut period in half. If you do that, then you should be good. So half of pi over 2 is pi over 4, and we're going to start, in a way, at opposite of finish. So negative pi over 4. Because the distance from negative pi over 4 to pi over 4 is pi over 2. So I'm going to go out pi over 4. I'm going to go out negative pi over 4. This is where we get our, that's not very straight, vertical asymptotes. With our amplitude, 3 and negative 3, what we're going to do is we're going to cut these two intervals in half. So half of pi over 4 is pi over 8, positive or negative. And we're going to get our 3 points. 0, 0. Pi over 8 would give us 3. Negative pi over 8 would give us negative 3, because tangent is symmetric over the origin, or odd. So we get this as 1 revolution for tangent. If you wanted to, the next one would be at 3 pi over 4. And then the halfway point there would be 3 pi over 8. And we would get the same thing. So I'm only asking you to do 1 revolution. But if you want to see what 2 would, you get this for 2. And again, the emphasis is here is to do all of these by hand. So last up, example 3, which is the tangent of 2x minus 1. And you see if this minus 1 is on the outside, this is going to be a vertical shift. And we haven't seen these yet, but I think we can handle it if I start introducing them now. So with this vertical shift, we're going to save that to the graph. So we're going to start amplitude, which is 2. Our period, which is pi over b, so that's just pi. So our finish is going to be half of our period, and our start would then be negative pi over 2. So we're going to draw our graph. We're going to go out pi over 2, and then back negative pi over 2. So normally, starting at 0, we're going to put in our amplitude as at 2 and at negative 2. Again, our halfway points, pi over 4, negative pi over 4. And here's the one thing that I want to say. So this minus 1, normally if we plugged in pi over 4, we'd get 1, or in this case it'd be 2. But we're going to shift this down 1, so we're only going to get 1 out. Normally, instead of being at the origin at 0, we're going to be at negative 1. And instead of being at negative 2, at negative pi over 4, we're going to be at negative 3, because everything gets shifted down 1. So if I make these kind of obvious, these are our 3 points that we're dealing with, and our tangent graph just got shifted down 1. So we can do vertical shifts. All that influences is our up and down. So here, instead of being at the origin, everything just got moved down 1. So our last bit would be cotangent, and then we are done graphing all of our trig functions. Okay, so starting with cotangent of our graph, we're just going to make things a little bit easier. So just like everything that we did with tangent, it's going to apply to cotangent. The only other thing, cotangent has vertical asymptotes every multiple of pi, or x equals k times x. That's what you'll see in the book. So instead of being at negative pi over 2 and pi over 2, cotangent is going to have vertical asymptotes at 0, pi, 2 pi, 3 pi. Cotangent is the nicer of the two functions. So, like always, our amplitude, we're going to look here, is 1. Our period for tangents is always going to be 2 pi over b. So this is just pi. And so because cotangent is nice, we can just say start at 0, finish at pi. And what I mean by that, both of these are vertical asymptotes. So with cotangent, we have 0. We go out to pi. We could also go out to negative pi if we wanted to. And all we need is the halfway point. So this is pi over 2. This one would be negative pi over 2. So with cotangent, if we're looking at the reciprocal here, if we're getting closer and closer to 0, we would be getting closer and closer to infinity. At pi over 2, we're 0. So cotangent is flipped. Now, we should also include our pi over 4 here and 3 pi over 4, which would be give us our 1, and this would give us our negative 1. Same thing here, be 0, halfway, halfway. this would be positive, this would be negative, and our graph would be like this. So tangent is odd, cotangent is not. Cotangent is the reverse of this. So we got one more, and then we're done with graphing tangent, cotangent, and you guys will have plenty of practice with these. So amplitude here is 4. Our period would be pi over b, so pi over 2. So that means we're still going to start at 0, and we're going to finish at pi over 2. So we go out pi over 2, and for our sake, I'm just going to do another one, 3 pi over 2, vertical asymptote, vertical asymptote, one more at 0, vertical asymptote. Okay, so our amplitude is 4. 1, 2, 3, 4. That means we go down 2, 3, 4. Our halfway point would be pi over 4, or here, 3 pi over 4. If we cut pi over 4 in half, we get pi over 8. This would be 3 pi over 8. At pi over 8, we would get 4. At 3 pi over 8, we would get negative 4. All we need to do, and at pi over 4, excuse me, we would get 0. Now we just connect the dots. So same thing here. Our tangent function is going to look something like that. So hopefully we can work with tangent. Tangent is difficult. It's the one unique case out of all the other ones. So this will take some time and practice, and if you don't practice it, then it's not going to be so good on the test. So it's important that we try graphing these as opposed to graphing sine and cosine.